Okay, good evening, everyone. So today we are going to discuss question number 4, SCL algebra. So the question is, all pictures are stored in a computer in tiny boxes called pixels. All of the pixels of an image have their color and opacity values respectively. For the color code, each pixel has its own red, blue, and green, which is known as RGB values, which specify the intensity of each color. With different values can add up to other colors, RGB values are in the range of 0 to 255. Hence, the chosen mode is 256. Okay, so this is the original image. From the original image, we can change the picture into a pixel form. So when you change the image from an original to a pixel form, it will help you to find the RGB color code. Okay, in order to change the image of an IC photo to an RGB color code, we need some part at this 6 to 6 pixels to translate the picture. So to translate the picture, to get that 6 to 6 pixels, you need to use a Paint app in laptop. Therefore, we can find the RGB color codes by each pixels. For example, pixel number 1, 231.194.167. The 231 is R, 194 is G, and 167 is B. And it follows with the others, like pixel 2, which is 250.220.192, which are RGB continuous.
Okay, thank you, Sweta. So we move on to the next step. So after we get the color code for each pixel, so we have to use the hash-cipher method to convert the code to send a secret message. So from the color code of each pixels, we need to make a key. So we can choose randomly from the alphabet of A to Z for each pixels, for each RGB color code for each pixels. So after we choose each alphabet, we have to change the alphabet to number according to the arrangement of alphabet. So we can see here A, B, C, D, E, F, G until Z, and we note it as 0, 1, 2, 3, 4, 5, 6, and so on. Okay, so as a result, we change the key to number. So as an example, we can see from the first row and column is A. So from the second table, we see that A is 0. So we choose 0 here. And the next one is S. So we can see S is 18. So we choose 18 here. And it goes the same for each key. And after we change each key to the numbers, so we have to note this table as A. So next, from the encryption of RGB color code, we divide it to code to red, green, and blue. So we can see from the table that has represented by Sweta, we see from the first column and row is 231, 194, and 167. So 231 is the R, 194 is G, 167 is B. So 231, we see from the red column, from the red table, so each first one is 231. The second one is G, so 194, we can see from the green table is 194. And for the blue, 167, we can see here, I choose 167 here. And it goes the same for each RGB color code. And after we have done it, so we have to notate each. For the R table, we have noted to B, G is D, and B is E.
Okay, next, by the help of Microsoft Excel, we can find the value of R, G, and B, multiplied value of key by using formula mod A, B, which is A is key, B is a red. Why I say B is a red? Because here, okay, we already group it as B is a red, D is a green, and E is a blue. Okay, after that, after we get all the value, we need to name for group, which K multiplied by R is Q, K multiplied by green is W, K multiplied by blue is T. Okay, next, from the value that we get before, we change it to mode 256 by using formula mode Q256. Okay, after we get the value, after that we will get the value. So here, K times So here are K times R, mode 256, we get the value, and so on for green and the blue one. Okay, next for decryption, we want the inverse of value key by formula inverse A. So decryption, the inverse of value key, we need after we find the value, we need to name the group as S. Okay, so it will easier lah later on. Next, we need to find the inverse of value key in mode 256 by using formula mode S256. After we get the value, we need to name the group as Z. That's all from me. Thank you.
Next, we need to find the inverse of value key in mode 256 by formula mode in bracket S, 256. So we find the inverse key that we get in decryption, which is S, and we just insert in the formula that we need to use. Then we will get the number of D, which is name is as Z. After that, find the value of RG and B multiplied value of key and inverse key in mode 256 by formula MMULT in bracket Z, Q. So Z is D that we find here at first, and then we insert the Q, which is K multiplied with R, K multiplied with G, and K multiplied with B. So we will get the value of P, O, and L. Next, from the value that we get before, we change it to mode 256 by formula mode in bracket P, and 256. Then we will get the value of mode 256 for DKR, DKG, and DKB. So if we see from here, we will get the real value, the original value of RGB color code that we get in this, which is B, D, and E. So 231, 194, and 167. As a proof, we will get the same value, which is 231, 194, and 167. So with the RGB values, the reception can recover the IC photo. So we will get the value, the message, the code that we want to send to our friend. So that's all from my group. Thank you.